Good morning to everyone. I am Sandhya from the Agricultural Engineering Department in the year of second year. Today I talk about the topic of demonstrate the uses of theodolite to measure a horizontal angle. First we can see about the introduction. The introduction contains the theodolite is an instrument which is used to measure the horizontal and vertical angles. This instrument was invented by the Danish astronomer named Romer in the year of 1960. This instrument is mainly inverted for measuring the celestial meridians such as stars and moons. After the century years, it was modified into the surveying instrument and which is used for the measuring the horizontal and vertical angles. Then principles. The principle is used for the it contains rotation of telescope, graduated horizontal circle, accuracy of measurements and readings. Rotation of telescope. The telescope can be rotated into the horizontal angle and both vertical angle. For measurement of the horizontal angles, it is rotated into the vertical axis. Next, graduated horizontal circle. The angular readings are taken in the telescope towards the different object. Accuracy of measurement. The angles must taken into the horizontal and vertical angles. These angles are taken by the both face left and face right, so the measurement are very clear and accurate. Then readings. The measured readings are taken into the field book. These horizontal angle readings are very accurate and clear. Objective part contains what we do in the in this measurement. First, the horizontal angles are measured in between 2 points or more. Two or more points. First, we can understand about this instrument and working principles of the instrument. This give the accurate and perfect value by our setup of the instrument and face left and face right of the readings. These face left and face right gives the most appropriate and accurate values of the area. This instrument must be handled with carefully and proper handling. These are adjusted for the field conditions. Then importance. Why we use this theodolite? For the purpose of surveying control, accurate positioning, mapping and plotting, engineering layouts. First, surveying controls. In the surveying, this theodolite are not only used for the horizontal angles measurement but also for the triangulation, traversing and establishing control points. In triangulation is nothing but triangulation is the area is divided into multiple triangles and then measured. Then accurate positioning. First, the instrument must be set up in accurate positioning, and then it is used for the relative measurement of the relative positions of the stations. Mapping and plotting. It is used for the mapping. We taken the readings from the area and then it is plotted into the map. Engineering language. It is used for the engineering purpose also, for the setting of the roads, railways, canals, buildings and so that it is also used for the engineering layouts. Classification. The instrument must be classified into many types, depends upon their features and functions. These are classified into some minor parts that are most rarely used, such as vernier theodolite, micrometer theodolite, optical theodolite, electronic theodolite. The major classification we used are transit theodolite and non-transit theodolite. These two theodolites are mostly used in our surveying purpose. First, role of transit theodolite. This transit theodolite can be rotated in through 180 in vertical angle about its horizontal circle. This telescope give the accurate value of the opposite direction. This vertical angle is fitted into this vertical circle is fitted into the with the telescope, so that telescope rotated with its vertical circle. I say the some parts of the transit theodolite that are contain various parts are like vertical circle, horizontal circle, bubble tube, foot screw, foot upper clamp, lower clamp. So many parts are it contain. Then role of non-transit theodolite. This non-transit theodolite cannot be rotated into the 180 for the about its horizontal angle. I say some example like Y theodolite and Everest theodolite. This cannot be rotated through the 180. It can be used for the limited survey and it can be used in the limited use. It can be suitable for the small survey and not for the large surveying purpose. It is it gives the less accurate values compared to the transit theodolite. This is can be used and suitable for this simpler horizontal measurement, not suitable for the accurate values and larger areas. Then measurement of horizontal angles. Horizontal angles are rotated about by operating the upper clamps, lower clamps, then foot screws. These measurements can be classified into two methods. These methods contain repetition and reiteration. These are various different procedures. Methods are repetition. These same in this horizontal angles and vertical angles are measured. In this, the horizontal angles are measured in several times. The one angle is measured in several times, so that we can reduce the errors. Then the values are very accurate for repeating the method. This reduce the errors such as instrument error, observer's errors, and eccentricity errors. Method of reiteration. This method is talk about the horizontal angles. It also gives the accurate value. That is the mission is the instrument is set up in one station and measure the all station around that instrument, so that we can get the very accurate and perfect value. It is the taken the 2 to 3 times of the value. The average values of the measured values are taken as the true value. This is very useful for the traversing measurements and triangulation surveying. It is most useful where the multiple angles are needed in one station. This is very helpful in triangulation survey and traversing survey. Triangulation survey. we can saw about the application. Lot of applications are available. First we can see about the triangulation survey. I already say triangulation survey is nothing but the land is divided into the multiple triangulation, then taking the readings. That is more helpful to take the measurement. So we divide the land into the multiple triangles. Traversing is nothing but determining the direction and bearings of the station points and setting out works. It is also works in the construction works, like railway construction, canals construction, tunnels, bridges. These type of constructions are done by this theodolite measurement of horizontal angles. Then astronomical observation. In introduction I saw the theodolite first inverted for the astronomical surveying, then only it is converted and modified to surveying purpose. It is used for astronomical observation, like latitude, longitude, and stars and moons. Some other applications are property and land surveys, then control surveys and construction projects, mining and tunnel survey. Property and land surveys, these are used for the determine the boundary of the properties and land records, and also used for the farm lands. Control survey, this provides the angular measurement of the control network in engineering projects, construction project. This is very helpful for the construction project. We previously see these are used for the construction purpose, like roads, construction of the roads, railways, tunnels and bridges. Mining and tunnel survey, this is a new one, mining and tunnel survey. That mining is underground process, so that theodolite methods are also used for the underground surveying and finding the direction and position of the minings, and also find the mining level in that underground. Then advantages: high accuracy, versatility, error minimizing, wide application. High accuracy, we see the method of repetition and the method of reiteration, also the high accuracy method. And then transist theodolite compared to non-transist theodolite, the transist theodolite have been high accuracy. The higher then the phase left and phase right are used to maintain a high accurate values. Versatility, versatility means it is not only used for the horizontal angles, it is also used for the measurement of the triangulation survey and traversing survey, so it is considered as the very versatility method. Error minimizing, by using the phase left and phase right, we can reduce the error, like eccentricity error, observer's error, like the errors are very reduced. Then wide applications, it is also used for the engineering purpose and construction purpose, load planning, mapping, so that it has a wide applications. So it is the main advantages of this theodolite. Disadvantages contain time consuming, requires skilled operators, instrumental sensitive, cost. Time consuming, we see the instrument should be set up in correct position, so that we can observe the very accurate value, so that accurate position is set up for the setup is taken sometimes, so that it consume little more time. Requires skilled operators. Students can operate this instrument, but the students taught by the skilled labors only, so that it is the sensitive machine, so we can require the skilled labors for operating this instrument. Sensitive, it is called a sensitive instrument, so we handled with care, and the readings are observed with carefully and handled carefully. Cost, compared to other materials like plane tables, compass, compared to others, it is very very cost effective instrument, so that we can handle it safely. Thank you.